Okay, Bismillahirrahmanirrahim. We start our lecture today. Last week we have seen a lot about the set, and then we have done a lot of exercises. Now for today we go for the function in the set theory. Another term is we want to mapping the relationship from the element of one set to another element for the another set. Okay, okay, mapping. Another name is mapping. We want to mapping. Okay, mapping. Okay, the relationship. Okay, this one for the recap. Last slide. We have uh, we have seen the set. It is an unordered collection of object, and then it contain the element, or we can call it as a member, an object in the set. And then we can have the element in the bracket notation. And then we have also seen the cardinality. Cardinality is the number of distinct member in the set. Cardinality. And then we have also seen the power of set, the set of all subset of a set. Okay, we have a power of set. Okay, we can define as 2a. Okay, and then we also have the Cartesian product of two set A and B. A multiplied by B is equal to AB, and then A is a member of A, and B element of set B. If one set A, set B. And also we have seen the union as O, and then intersection is N. Okay, and then we have differences. Okay, differences which can describe by X is the member of A, and also X is not a member of set B. Okay, and then we have a complement. Universe of discourse is minus by the element of set A. For example, we have here. Okay, we have A. Okay, this one is complement of A, and then this one is universe of discourse. Okay, and then we have also seen the identities similar to those from the logics. Okay, this one from De Morgan law. Okay, we have seen this one. A union by B is equal to A complement A intersection by set B complement. Okay. Okay, this one also same. This one for the union and this one for the intersection. Okay, and then for the definition, let A and B be the set, a function from A to be assignment of exactly one element of B to each element of A. Okay, this one is the function from A to B is assignment exactly. We write a function as fa equal to B, whereby the B is a unique element of B assigned by the function f. Okay, this one f we define as a function to element of A, element of A. Okay, and then we can also state f is a function from A to B. We can write to from A, okay, to B. Okay, do you have any question for the function? Okay, function is we want to write the element, and then we select the function is assignment from one element to another element. Okay, this one is the function. Okay, next, can I proceed? Boleh saya proceed ke? Ada soalan ke setakat ni? Function. Okay, and then most importantly, it is a unique element. Unique element that we assign from B. Okay, and then we can also go through to another definition. If f is function from A to B, we can say that A is domain of f and B is a codomain of f. Okay, okay, we can say A is a domain. This one is a main domain, and then B is codomain. Codomain. And then if FA is equal to B, we can say that B is the image of A, and then the range of F is the set of all images of element of A. Okay. Okay. Most importantly, if you say the study of the function, we need to focus how function mapping individual element of each domain to the codomain. We also focusing on the pre-image of in an individual element in each codomain. For example, if f are uh, real number implies b, r is real number also is defined by fx equal to x power of 2 lah. Okay, for example, if we have f, okay, f, okay, we can define fx. Okay, and then for each x, okay, we can say for each x is a member of rational number. Okay, R is a rational number. Okay, and then how we can prove this one? We can prove if f 2, we can put 2 is equal to 4. We can say f map 2 to 4, or we can say that 4 is the image of 2 under the function of f. Okay, for example, okay, we have f2 is equal to 4, and then we can say that f maps 2 to 4, or we can say that the image of 2 under under the function of f. Okay, since the f 2, if you put 2, is implies 4, that x minus 2 or x equal to negative 2, we can say that the pre-images of 4 are 2 and negative 2 are the set of pre-images of 4 is negative 2 and 2 lah. Okay, we can say that since equal to 4 implies that x equal to 2, or you can say x equal to negative 2. Okay, negative 2 pre images of 4. Okay, pre images of 4 are 2 and negative 2 because if you multiply negative 2 by negative 2 is equal to 4. Okay, we can also define that set okay, of pre-images of 4 is 2 and negative 2. Boleh tulisan tak berapa cantik sangat. Boleh ikut ke? Qayyum, is it okay for you? Qayyum, boleh ke? Boleh. F we maps 2 to 4 lah. And then the image of 2 under the function of f lah. Because we know the function f is a dominant domain, and then okay, f is a domain, and then we map for the codomain, codomain, or we can call it as a pre-images lah. Okay, and then suppose we have the student as the domain in the class that assign a letter grade from the set A, B, C, D, and F. Let G be the function that assign to the grade of the students. Okay, we have codomain and we have range. Okay, we have domain and codomain. We have defined this one is a domain, this one is a codomain, and then we have range. Okay. Okay, we have range from A until F, and then we map. Okay, we map and assign a grade to a student from domain to codomain, and then we have the range. Okay, we have Chevers, Stoke, there's Dozier, and Holland. As you can see here, for the codomain, the range is from A to D because the grade uh, has a lot of grades, and then for the student, all student has passed. Okay. Okay, consider the function f z. Okay, for the domain integers. We have integers and negative integers. For this one, we define as integers. And then codomain is also integers that assign the square of the integers to this integer. And then how can you write a function? This function fx equal to x power of 2 functions. What is domain of f? Integers. What is codomain of the f? Codomain is also f, also z integer. And then what is the range of f? Non-negative integers from 1, 4, 9, and so on. We have 1 for 9, and then we have 16, we have 25, okay, 2 power of 2, 3 power of 2, 4 power of 2, 5 power of 2, 6 power of 2, and so on until, okay. This one is non-negative integers. Okay, okay, and other than that, we can also have a natural number. We have a positive number, positive integers, and then we have two rational numbers. Okay. Okay, and then for the range mapping, we define range. Okay, because we have domain and codomain. Okay, for this one we have domain and codomain. Okay, uh, domain here is integers. Integers. Codomain also the integers. Okay, and then we have range. Okay, we have range here. Okay, 0, 1. Okay, we have fx. Okay, and then we map. Okay, we're mapping the uh, function to x. Okay, fx equal to x. Okay, and then fx equal to x, and then x power of 2. And then we have negative 1. Negative 2 is 4. Negative 1 is 1. 0 to 0. 1 to 1. And 2 power of 2 is 4. 3 to 9, and so on. Okay, this one we map the range. Mapping the range. Okay, and then here we can have the when we want to map to one function. No value in the range is being implemented or used by more than one value in the domain, which means that it has to one function. Okay, one domain is we reimage or mapping to only one codomain. Okay, this one we can also call it as injunctive. Injunctive. Okay, in mathematics, an injunctive function is function of f that map distinct element to distinct element. That f equal to f. Okay, uh, and implies that x1 equal to x2. In other words, every element of function codomain is the image of at most one element of its domain. Okay, we can say f equal to f, fx equal to fy, and then x equal to y for all x and y in the domain of f. and we map at least, okay, at least one. In other words, every element of function codomain is the image at most one element of its domain. Okay, we have domain and we have codomain. Okay, and then domain is X, codomain is Y, and then we map one by one. Okay, okay, you can see this one is a codomain. Domain for codomain is mapping at at most, okay, one element. Okay, in other words, for all x, for all y, fx equal to fy is implies the x equal to y, or using the contrapositive. Okay, we can say that for all x, for all y, x is not equal to y implies the fx is not equal to fy. If you use the contrapositive, it negate negate the statement. Okay, do you have any questions so far? Is it okay? Okay, injective function is one to one lah. We want to map one to one element is function of f that mapping a distinct element to distinct element lah, which means that if you have a, let's say a, b and c, it map to 1, 3 and 4, and then the range is not be as same as a domain. Okay, let's say if you have a domain 3 and then you have codomain 4, the the size, but you must map exactly the same element for domain. Okay, let's say domain have 3, and then you must mapping from the domain to codomain also 3 lah. Okay, okay, or else we can have a draw. I draw a little bit for you. Okay, another example. Okay, we have x1, x2 lah. Okay, and then we have function. Okay, whereby the real number implies the real domain real number, codomain is real number also, and then fx. Okay, this one we can call it as injective. Okay, okay, we have A, we have B, we have C, we have D, 4, and then we have range 1, 2, 3, 4, 5. Okay, okay, let's say we map like this. Okay, okay, if you put 2x, For this one is 2x is 2, 6, 8, 10 lah. Here is injective eh. Okay, and then the function fx equal to x power of 2 from the set of integer. The set of the integer, is it 1 to 1? Okay, do you have any question? Is it okay? Yes? Yeah, slide mana? Ya, slide tadi yang mana? Okay, okay. Uh, satu tu, satu tu merujuk kepada x2 lah. 2a. Bukan, ini saya bagi contoh daripada real number to real number. Kalau ni kita bagi contoh satu lah. Maka dia punya value dia. Kalau kita gantikan satu kat sini, dia jadi 2 lah. Kalau kita jadi 2 sini, jadi 4 lah. Kalau 3 sini akan jadi 6 lah. Okey, yang saya nak tunjuk yang kat sini adalah dia injective. Injective maksudnya dia kena map at least satu elemen. Boleh, Ella Watton? Okay, and then one-to-one function. This one from the set of integer to set of integers one-to-one. Okay. Okay, this one is a question. Is the function fx equal to x power of 2 from the set of integers or the set of integers one-to-one? Okay, we can say that 1 uh, power of 2 is equal to negative 1 power of 2, but 1 is not equal to negative 1. And then the answer is no lah. Okay. Okay, and then number 2 is the function of fx equal to x plus 1. Is it this one is 1 to 1? Okay. And then if you map for all x for all y, okay, and then x plus y equivalent to y plus 1, x plus 1 is not the same uh, by y plus 1 only when x is not equal to y, and then the statement is yes. Okay.